In this part, we are gonna solve question number 40 to question number 52 of Mathematics ESSLCE of the year 2012-2013 Ethiopian calendar. Question number 40. Which of the following is the standard form of equation of ellipse with vertex 3,1, 3,9 and minor axis of length 6? The standard form of equation of ellipse is given by the formula x minus h the whole square divided by a square plus y minus k the whole square divided by b square is equal to 1. The center of ellipse, that's halfway between the two vertices, is 3 plus 3 divided by 2, 1 plus 9 divided by 2, which is equal to 3 plus 3 is 6 divided by 2 is 3, 1 plus 9 is 10 divided by 2 is 5. Since the x values of both vertices are the same, the ellipse stretches further in the vertical direction and hence B is the major axis. Half of the length of the major axis, that's the distance between center to one of the vertex. In this case, let's consider center to the center 3,5 to one of the vertex, that's 3,1, is given by the formula B is equal to the square root of 3 minus 3 the whole square plus 5 minus 1 the whole square, which is equal to 3 minus 3 is 0, 0 square is 0. So we left with 5 minus 1 the whole square. 5 minus 1 is 4. Then square root of 4 square is 4. Half of the length of the minor axis, that is A, is equal to, the minor axis is 6 divided by 2. 6 divided by 2 is equal to 3. Thus, equation of ellipse is x minus 3 the whole square divided by 3 square plus y minus 5 the whole square divided by 4 square, which is equal to 1. This implies x minus 3 the whole square divided by 3 square is 9 plus y minus 5 the whole square divided by 4 square is 16, which is equal to 1. Hence, choice C is the correct answer. Question number 41. Let vector u is equal to 2, 0 and vector v is equal to negative 1, 3 be two vectors in a plane, and vector w is equal to negative 3 times vector u plus 2 times vector v. Which of the following is a unit vector in the direction of w in terms of the standard unit vector I and j? Vector u and v can be expressed in terms of standard unit vector I and j as u is equal to 2i plus 0j and v is equal to negative 1i plus 3j. Vector w is equal to negative 3 times vector u plus 2 times vector v, which is equal to negative 3 times vector u is 2i plus 0j plus 2 times vector v is negative 1i plus 3j, which is equal to negative 3 times 2i is negative 6i plus negative 3 times 0j is 0j plus 2 times negative 1i is negative 2i plus 2 times 3j is 6j, which is equal to negative 6i plus negative 2i is negative 8i plus 0j plus 6j is 6j. The question is not about vector in terms of standard unit vector I and j, but unit vector in the direction of w in terms of standard unit vectors I and j. Thus, unit vector in the direction of w is given by the formula the vector w divided by the magnitude of w, which is equal to w is negative 8i plus 6j divided by magnitude of w is square root of negative 8 square plus 6 square, which is equal to negative 8i plus 6j divided by negative 8 square is 64 plus 6 square is 36, which is equal to negative 8i plus 6j divided by 64 plus 36 is 100, which is equal to negative 8i plus 6j divided by square root of 100 is 10. This is equal to negative 8i divided by 10 is negative 4 over 5i plus 6j divided by 10 is 3 over 5j. Why we call this vector a unit vector? Because its magnitude is 1. Thus choice D is the correct answer. Question number 42. Let P and Q are propositions with truth value true and false respectively. Then which of the following is correct? Let's check each of the choice. Choice A, P or Q and negation of P, which is equal to P is given as true or Q is given as false and negation of P is false, which is equal to true or false and false is false, which is equal to true or false is true. Choice A is correct. Choice B, P implies Q and P, which is equal to P is true implies Q is false and P is true, which is equal to true implies false is false and true. False and true is false. Choice B is not correct. Choice C, P or negation of Q implies Q, which is equal to P is true or Q is false, so negation of Q is true, implies Q is false, which is equal to true or true is true, implies false, true implies false is false. Choice C is not correct. Choice D, negation of P implies Q. P is true, so negation of Q is false, implies false. False implies false is true. Choice D also not correct. Hence the correct answer. Hence choice A is the right alternative. Question number 43. The following is a graph of a function y is equal to x to the power of m over n, where m and n are positive integers and n different from 0. This is the graph. Which of the following is true about m and n? Y is equal to x to the power of m over n can be rewritten as y is equal to x to the power of 1 over n, the whole power of m, which is equal to the nth root of x to the power of m. The curve is sharply increasing. The expression at the power, that is m over n, is greater than 1. M over n greater than 1. This implies m greater than n. The graph starts from 0, 0 and moves upward in the first quadrant, meaning the expression n's root of x to the power of m is always greater than or equal to 0. N's root of x to the power of m is always positive only when the index number n is even. Thus, m greater than n and n is even. So choice C is the correct answer. Question number 44. Given a rational function f of x is equal to 2x plus 4 divided by x minus 1, which of the following is not true about its graph? The graph has a y-intercept at 0, negative 4. Y-intercept or x equal to 0 is y is equal to 2 times 0 plus 4 divided by 0 minus 1, which is equal to 2 times 0 is 0 plus 4 divided by 0 minus 1 is negative 1, which is equal to 0 plus 4 is 4 divided by negative 1 is negative 4, or the y-intercept is at 0, negative 4. Choice A is true. B, x-intercept is negative 4, 0. X-intercept or y is equal to 0 is equal to 2x plus 4 divided by x minus 1. 0 means 0 over 1. So multiplying crisscross, 1 times 2x plus 4 is 2x plus 4, which is equal to 0 times x minus 1 is 0. This implies taking positive 4 to the other side of equality and dividing by 2, we will find x is equal to negative 2. Or the x-intercept is negative 2, 0. So choice B is not true. Choice C, the horizontal asymptote is y is equal to 2. Horizontal asymptote is the quotient of the leading coefficients since the degree of numerator is equal to the degree of denominator. Therefore, y is equal to the leading coefficient is the coefficient of the highest power. The highest power at the numerator is x, so the coefficient of x is 2 divided by the highest power at the denominator is again x. The coefficient of x at the denominator is 1. So 2 divided by 1 is equal to 2. So choice C is true. Choice D, the vertical asymptote is at x is equal to 1. Vertical asymptote is a vertical line that makes the denominator 0. The denominator is x minus 1, which is equal to 0. Taking negative 1 to the other side of equality, we will find x is equal to 1. Thus, choice D is also true. So the answer is choice B. Question number 45. Let f of x is equal to square root of x plus 2 and g of x is equal to x squared minus 1. What's the domain and range of the composition of f with g or fog respectively? Fog is equal to f of g of x, which is equal to f of g of x is x squared minus 1. F of x squared minus 1 is equal to the square root of x squared minus 1 plus 2. Minus 1 plus 2 is plus 1, so the square root of x squared minus 1 plus 2 is equal to square root of x squared plus 1. The domain x squared plus x always greater than or equal to 0. So x element of or real number is the domain. Range for any x squared plus 1 is always greater than or equal to 1. Thus the range is 1 up to infinity, including 1. So choice C is the correct answer. Question number 46. Given the function f of x is equal to 2x squared minus 3x plus 1, what is the slope of the line passing through the points -1, f of -1 and 2, f of 2? Determining the two order pairs is sufficient to determine the slope. Thus let's calculate f of -1 and f of 2. F of -1 is equal to 2 times -1 squared minus 3 times -1 plus 1, which is equal to 2 times -1 squared is 1. -3 times -1 is positive 3 plus 1. 2 times 1 is 2. 2 plus 3 is 5. 2 times 1 is 2. 2 plus 3 is 5. 5 plus 1 is equal to 6. F of 2 is equal to 2 times 2 squared minus 3 times 2 plus 1. 2 times 2 squared is 4 minus 3 times 2 is 6 plus 1. 2 times 4 is 8. 8 minus 6 is 2. 2 plus 1 is equal to 3. The order pairs -1, f of -1 and 2, f of 2 is equal to -1, 6 and 2, 3. The slope m of order pairs, point P with an order pair x sub 1, y sub 1 and point P2 with an ordered pair x sub 2, y sub 2 is given by the formula m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, which is equal to y sub 2 is 3 minus y sub 1 is 6 divided by x sub 2 is 2 minus x sub 1 is -1, which is equal to 3 minus 6 is -3 divided by 2 minus -1 means 2 plus 1. 2 plus 1 is 3, which is equal to -3 divided by 3 is -1. Choice C is the correct answer. Question number 47. F of x is equal to 4 minus x squared sine x. Then, which of the following expressions describe first derivative of f of x? F derivative of x is equal to the derivative of 4 is 0 minus the derivative of x squared sine x, which is equal to 0 minus x squared sine x derivative is negative sine x, negative x squared sine x derivative. This is the derivative of the product of two functions. The product rule of derivation states that if h of x and g of x are both differentiable, then the derivative of the product of the two functions is given by the formula h of x times g of x derivative is equal to the derivative of h of x times g of x plus h of x times the derivative of g of x. In this particular case, h of x is equal to x squared and g of x is equal to sine x. Thus, f derivative of x is equal to negative. The derivative of x squared is 2x times sine x plus x squared times the derivative of sine x is cos x, which is equal to x is there in both terms. Then, taking x as a common factor, -1 times x, 2x sine x divided by x is 2 sine x, plus x squared cos x divided by x is x cos x. Thus, choice C is the correct answer. Question number 48. F of x is equal to 1 over 1 minus square root of x the whole square. Then, f derivative at 4 is equal to, f of x is equal to 1 over 1 minus square root of x the whole square can be rewritten as 1 minus square root of x the power of -2. Then let's determine f derivative of x. F derivative of x is equal to taking -2 to the front times -2 times 1 minus square root of x the power of -2 minus 1 times the derivative of the expression inside the bracket, that means the derivative of 1 minus square root of x. 1 minus square root of x can be written as 1 minus x to the power of 1 over 2 derivative, which is equal to negative 2 times 1 minus square root of x, the power of negative 2 minus 1 is negative 3, times the derivative of 1 is 0, minus, taking 1 over 2 to the front, that's 1 over 2 times x to the power of 1 over 2 times minus 1, which is equal to negative 2 times 1 minus the square root of x, the power of negative 3 means negative 2 divided by 1 minus the square root of x, the power of 3, times 0 minus 1 over 2, x the power of negative 1 over 2 minus 1 means negative 1 over 2, x the power of 1 over 2 minus 1 is negative 1 over 2, which is equal to negative 2 divided by 1 minus the square root of x the power of 3 times negative 1 over 2 root x. 2 cross out by 2, so we left with negative 1 times negative 1 at the numerator is equal to 1 divided by square root of x times 1 minus the square root of x to the power of 3. Then let's determine f derivative at 4. F derivative at 4 is equal to 1 divided by square root of 4 times 1 minus the square root of 4 the whole cube, which is equal to 1 divided by square root of 4 is 2 times 1 minus square root of 4 is again 2 the power of 3, which is equal to 1 over 2 times 1 minus 2 is negative 1, negative 1 cube is negative 1, which is equal to 2 times negative 1 is negative 2, 1 divided by negative 2 is negative 1 over 2. Thus choice D is the correct answer. Question number 49. Consider the sequence whose terms are a sub 1 is equal to 6 and a sub n plus 1 is equal to negative 1 over 3 times a sub n for n element of natural number. Then what is the sum of the first 10 terms? The consecutive terms of a sequence a sub n and a sub n plus 1 are related by the formula a sub n plus 1 is equal to a sub n plus d if the sequence is arithmetic, and a sub n plus 1 is equal to r times a sub n if the sequence is geometric. In the given sequence, a sub n plus 1 is equal to a constant times a sub n. Thus, the sequence under inquiry is a geometric sequence with a common ratio r is equal to negative 1 over 3. The sum of the first n terms of a geometric sequence with first term a sub 1 and a common ratio r is given by the formula s sub n is equal to a sub n times 1 minus r to the power of n divided by 1 minus r, which is equal to a sub 1 is given as 6 times 1 minus the common ratio is negative 1 over 3, the power of 10 divided by 1 minus negative 1 over 3, which is equal to 6 times 1 minus negative 1 over 3 is the power of 10 divided by 1 minus negative 1 over 3 is 1 plus 1 over 3, which is equal to 6 times 1 minus negative 1 over 3 is the power of 10 divided by 1 means 3 over 3, so 3 over 3 plus 1 over 3 is equal to 4 over 3, which is equal to multiplying the numerator and the denominator by the reciprocal of the denominator, that is by 3 over 4, we will find 6 times 3 divided by 4 times 1 minus negative 1 over 3 is the power of 10, which is equal to by 2, 3, by 2, 2, so 3 times 3 is 9 divided by 2 times 1 minus negative 1 over 3 is the power of 10. Thus choice D is the correct answer. Question number 50. Which one of the following is a row reduced echelon form of a matrix, that is a 3 by 3 matrix, with element of first row 1 1 1, elements of second row 2 1 3, and elements of third row 4 negative 1 4. A matrix will be in row reduced echelon form if 1. The first non-zero element, also called pivot element or leading entry of each row is 1. Second, the pivot element is the only non-zero element in the column, or numbers above and below the pivot element are 0. Third requirement, the number of zeros preceding the first non-zero element in each non-zero row except the first row is greater than the number of such zeros in the preceding row. The fourth requirement, a zero row, if there is, comes at the bottom. Let's go through the following steps to convert the matrix into reduced echelon form. First, make the first element of row 1 1. It's by default 1. If it's a number different from 1, we have to convert it to 1. Second, we have to conduct row operation to convert the element under 1 in first column to 0, because this is the only non-zero element in this column. That is, 2 from second row and 4 from third row have to be converted to 0. Focus on the pivot elements of row 1 for such conversion. To make 2 to 0, either we have to add -2 or subtract 2. Thus, the row operation needed in this step is -2 times row 1 plus row 2, and then put it in row 2. First row element will become the same, 111. Second row element, -2 times 1 is -2 plus 2 is 0. -2 times 1 is -2 again, plus 1 is -1. -2 times 1 is -2, plus 3 is 1. The next row, that's the third row, we have to convert 4 from the third row to 0. To make 4 to 0, either we have to subtract 4 or we have to add -4. Thus, the row operation needed in this step is -4 times row 1 plus row 3, then put it in row 3. -4 times 1 is -4, plus 4 is 0. -4 times 1 is -4, plus -1 is -5. -4 times 1 is -4, plus 4 is 0. Convert the leading entry of row 2, that's -1 to 1. Just multiply row 2 by -1 and then put it in row 2. Row 1 and row 3 will become the same. -1 times 0 is 0. -1 times -1 is +1. -1 times 1 is -1. The fourth step, convert second column elements above and below the leading entry or pivot elements of row 2 to 0, because this is the only non-zero element in this column. That is, the second one from row 1 and -5 from row 3 have to be converted to 0. Row operation needed in this step, the element to be converted to 0 in row 1 is 1. Just simply subtract row 2 from row 1 and put it in row 1. That's 1 minus 0 is 1. 1 minus 1 is 0. 1 minus -1 means 1 plus 1, which is equal to 2. Row 2 will become the same. That's 0, 1, -1. Row operation needed in the third step. We are going to convert -5 to 0. So we have to add +5. Thus, to obtain +5, multiply row 2 by 5, and then plus row 3, put it in row 3. 5 times 0 is 0, 0 plus 0 is 0. 5 times 1 is 5, 5 plus -5 is 0. 5 times -1 is -5, -5 plus 0 is -5. Step 5, convert the pivot elements of row 3, that's -5 to 1. Simply multiply row 3 by -1 over 5 and then put it in row 3. Row 1 and row 2 will be the same. 0 times -1 over 5 is 0. 0 times -1 over 5 is 0. -1 over 5 times -5 is 1. The last step, or step 6, convert the last column elements above the leading entry or pivot elements of row 3 to 0. That's convert -1 from row 2 and +2 from row 1 to 0. Operations needed for this step: multiply row 3 by -2 plus row 1 and then put it in row 1. -2 times 0 is 0, plus 1 is 1. -2 times 0 is 0, plus 0 is 0. -2 times 1 is -2, plus 2 is 0. Operations for the second row: add second row and third row and put it in row 2, because -1 in second row is the direct opposite of +1 in row 3. Thus, 0 plus 0 is 0. 1 plus 0 is 1. -1 plus 1 is 0. Row 3 will be the same. This last matrix fulfill all mandatory requirements. That's the pivot element of all rows is 1. The pivot element is the only non-zero element in the column. Third, the number of zeros preceding the non-zero element in each non-zero row except first row is greater than the number of such zeros in the preceding row. Thus, Choice B is the correct answer. Question number 51. If z is equal to -1 plus I and w is equal to 1 minus 3i, what is the simplified form of 5z over w plus magnitude of z squared times a conjugate of w? 5z divided by w plus magnitude of z squared times the conjugate of w is equal to 5 times z means -1 plus I divided by w is 1 minus -3 plus the magnitude of z square is -1 square plus 1 square times the conjugate of w. To determine the conjugate of w, just take the opposite of the sign in front of the imaginary part. The imaginary part is 3i. The sign in front of 3i is negative. So the conjugate is 1 plus 3i, which is equal to 5 times -1 is -5 plus 5 times I is 5i divided by 1 minus 3i plus -1 square is 1 plus 1 square is 1 times 1 plus 3i, which is equal to simplify this first expression, multiply both the numerator and the denominator of the expression by the conjugate of 1 minus 3i. The conjugate of 1 minus 3i is 1 plus 3i. So -5 plus 5i times 1 plus 3i divided by 1 minus 3i times 1 plus 3i plus 1 plus 1 is 2 times 1 plus 3i. -5 times 1 is -5. -5 times 3i is -15i. 5i times 1 is 5i plus 5i times 3i is 15i square divided by 1 square is 1 minus 3i square plus 2 times 1 is 2 plus 2 times 3i is 6i, which is equal to -5. -15i plus 5i is -10i plus 15 times I square is -1 divided by 1 minus 3 square is 9 times I square is -1 plus 2 plus 6i, which is equal to 15 times -1 is -15. -15 plus -5 is -20 minus 10i divided by 10 plus 2 plus 6i, which is equal to -20 divided by 10 is -2. -10i divided by 10 is minus I plus 2 plus 6i. -2 plus 2 is 0. -I plus 6i is 5i. 0 plus 5i is 5i. Thus, choice C is the correct answer. Question number 52. Consider the experiment of rolling a die whose sample space is 1, 2, 3, 4, 5, and 6. If two dice are rolled simultaneously, then what is the probability that a prime number turns up on one of the die and a composite number on the other? Prime numbers in the sample space are 2, 3, and 5. The probability that a prime number turns up on one die is 3 over 6. Composite numbers in the sample space are 4 and 6. The probability that a composite number turns up on one die is 2 over 6. Thus, the probability the prime number turns up on the first die and a composite number on the second die is equal to 3 over 6 times 2 over 6, which is equal to 1 over 6. The probability that a composite number turns up on the first die and a prime number turns up on the second die is equal to 2 over 6 times 3 over 6, which is again 1 over 6. Therefore, the probability that a prime number turns up on one of the dice and a composite number on the other die is equal to 1 over 6 plus 1 over 6. 1 over 6 plus 1 over 6 is equal to 2 over 6, which is equal to 1 over 3. Choice C is the correct answer. That's all for this lesson. See you in the next episode.